and welcome to the Louisiana Energy Policy Simulator launch webinar. I am Sarah Spengeman, the Deputy Director of Communications for Energy Innovation. Energy Innovation is a nonpartisan climate and clean energy firm. Before we get started, just a few logistics. Everyone is on mute, but we encourage you to ask questions using the question box. And after the presentations, we'll answer those questions. And if we don't get to your question today and you have a question about modeling, you can feel free to email us at policy@energyinnovation.org. The webinar is being recorded and everyone who registered will receive a recording. We will also host the recording on our website, and I believe the governor's office will also be hosting it on their YouTube channel as well. And so I want to take a minute now to quickly introduce our speakers. We are delighted to have with us today Lindsay Cooper, who is the policy advisor from the Office of Louisiana Governor John Bel Edwards. And then we also have with us Allison DeYoung, who is the Senior Planner and Policy Researcher with the Water Institute of the Gulf. And then from our own team, we have Olivia Ashmore, who is a Policy Analyst at Energy Innovation. And then we also have joining us Kyle Clark Sutton, who is the Manager of Analysis for the US program at RMI, and who has been a close partner with us on developing the state EPS models. So without further ado, I'm now going to pass it over to Lindsay.
Thanks so much, Sarah, and good afternoon, everyone. Thank you so much for joining us for this really exciting and long anticipated launch of the Energy Innovations Energy Policy Simulator tool for Louisiana. I'm Lindsay Cooper, as Sarah mentioned, policy advisor to Louisiana Governor John Bel Edwards and project manager for his Climate Initiatives Task Force. And I'm joined today by my colleague Allison DeYoung and Olivia Ashmore at Energy Innovation. On today's webinar, I'll discuss Louisiana's efforts as a state to drive down our greenhouse gas emissions and how this tool will help us get there. And then my colleague Allison will dive into how this tool is being used in our Louisiana climate planning process, before Olivia then provides a detailed demonstration of this tool and how it works. So in August of 2020, our Governor Edwards signed an executive order establishing emission reduction goals for Louisiana. And our eventual goal is net carbon neutrality by 2050. This is in line with action of 25 other state governors, similar targets they've set, and leaders of 197 countries worldwide. But while our goals are similar to many others, these are still going to be extremely difficult to achieve. And we know that significant action will be required to meet these goals. So with the governor's executive order, he also established a climate initiatives task force to develop a climate action plan that puts Louisiana on a path to reduce emissions and to meet our goals. So this task force, a 23-member body of state agencies, industry, utility, and community representatives, has been working tirelessly to develop an action plan that balances interests and really confronts the unique emission profile of Louisiana. And our deadline for developing this action plan is February of 2022. So from the task force's inception, Governor Edwards has emphasized the need for science-based decision-making, as well as people-centered approaches that drive our process. So Energy Innovations Policy Simulator really helps us do both of those things, modeling the anticipated GHG reduction impact, as well as public health benefits of various climate policies in the EPS tool, allows the task force to make informed decisions and to focus Louisiana-specific policy refinement and feasibility through the task force. Having models that policymakers can use is essential, and equally important is having tools that can be accessed and understood by the public. Climate action requires action of all of us and hard decisions, which we must make with the best information available. And I'm incredibly grateful for the hard work of the Energy Innovation team this year for making this tool possible. They've partnered with us to develop and redevelop and rework and explain this tool multiple times over the past months. And we're really proud of the product to introduce today. So with that, I will hand over to Allison DeYoung, who will dive into more details on our climate planning process and the role of this tool in it. Allison, the floor is yours.
Awesome, thank you so much. Let me get my screen up here. Let's see if this works. Can you guys see my, this looks good, I think. Awesome. Well, thank you, Lindsay. Thank you, Energy Innovation. I'm really excited to be here and to talk to you about how we've been using the tool in the Climate Initiatives Task Force planning process. My name is Allison DeYoung. I'm a senior planner and policy researcher at the Water Institute of the Gulf. We are a not-for-profit, independent applied research and technical services institution based in Baton Rouge, Louisiana. I'm personally coming to you, obviously, from my home office in New Orleans. And as Lindsay mentioned, we are working on this because of the executive order signed by Governor Edwards in 2020. And this sets our goals in line with the Paris Agreement. And we're working, this is really important because Louisiana, despite being a smaller state in population, we are a very high state in terms of emissions. We have our 8th in total state emissions. And those emissions look a lot different than the national emissions profile. A lot, as a country, most of our emissions come from transportation and electric power sectors. 2/3 of our emissions in Louisiana are from industry. So we have a totally different path towards net zero than than a lot of different places. And so we're approaching this a little bit differently also. We have the task force set up by the executive order, but we also have 4 advisory groups on equity, science, finance, and legal. And we have 6 sector committees working to develop recommendations and actions for the plan. So this is a really collaborative, inclusive process that is looking to get the best ideas possible. And we're using what we call a structured decision-making process for this plan. And structured decision-making is a method of codifying common sense into a planning process that everyone can understand and participate and that is transparent. It is not a prescription for a rigid approach for problem solving. So it is not prescriptive, but it is structured. And so in the PROACT framework, we define the problem and decision context. We determine the objectives, we identify alternatives, forecast consequences, evaluate the trade-offs, make the decision and take action. Ooh, there's more clicking than I thought. And in this hybrid approach that we're using, we're kind of merging this with a state climate planning process. And so we have different places where we are incorporating the different people involved in this process, right? The task force helped us determine our fundamental objectives. The sector committees and the public submitted action proposals to help us identify alternatives. The advisory groups and this Louisiana EPS tool are helping us forecast consequences in 2 different rounds. And then the task force and the governor will evaluate and evaluate the final plan. So this is an inclusive, collaborative, transparent process. And we're really excited, and I think it's been a good framework to try and do climate action in this state. So a little bit more on kind of the different steps in the process and where this EPS tool comes in. As I mentioned, we defined the problem context using the executive order. We have to proactively work to reduce the greenhouse gases in our state. When we determined the objectives, this is, I think, a really critical piece because we, of course, want to reduce greenhouse gas emissions, but we also need to pay attention to and care about the ways in which we do that and what happens when we try and do that. So we have other objectives involving quality of life, creating a more equitable society, strengthening the economy and workforce, because those are important to us in how we reach our goals. And when we identified alternatives, we did so at multiple scales because we know that achieving these targets is not going to happen just through one level of action. It requires acting at high level and at a detailed level. And so we've been working at multiple scales, including the portfolio level, the overall level, strategies, high level paths to reducing greenhouse gas emissions, and actions, which are specific and implementable. And we received over 171 action ideas from the public when we submitted, and those are becoming pieces of the plan. So forecasting consequences, this is where we've really been using the tool, and I'm excited to talk about that. In the first round of consequence analysis, which was earlier this year, we created 5 hypothetical strategy portfolios. And these are big picture views of ways in which we could try to do climate action, although none of them were specifically net zero portfolios. They represented trying to turn up the dial on a specific kind of strategy to see how far that would get us. And so what we did was we built all of these portfolios in the EPS tool when it was in its beta format. And we used that as a way to try and evaluate how far these different strategies could get us in terms of getting to our net zero. And we also reviewed national and global pathway models and some other studies to try and fill in the gaps because they were structured at such a high level. But the tool really showed us that we couldn't really eliminate any of the options. We needed to try everything because our emissions are so difficult to reduce that we don't really have the luxury of leaving aside any kind of strategy. And so from there, we created a draft action and strategy portfolio. And so now we are conducting the second round of consequence analysis on that portfolio. And that'll actually be presented to the task force next Tuesday at the 26th. And this will analyze the consequences of our best first pass of the draft portfolio of actions and strategies in the plan. And so I'm going to be presenting on that to the task force next week. But again, it was a similar process of trying to build the portfolio fully in EPS and using the tool to determine how far this gets us and also to try and learn from it. And I want to talk about that a little bit because I think it's we're not using this tool as a magic 8-ball, right? This is one analysis that we're doing on these consequences, but it's not a definitive yes or no answer. Part of the great thing about modeling tools like the Louisiana EPS is that if you understand them, then you can adjust the inputs and even the outputs to help you learn about how you want to implement and design policies for your specific place. And in Louisiana, that's certainly the case because the policies are not necessarily in the tool available that Olivia is going to talk about in a second. They're not necessarily a one-for-one for the actions in our plan. And that's because it takes many actions to add up to the policy that it would look like in the tool. We have to think about things like feasibility and who's in charge and who would set and enforce these policies. And also, looking on the other side, interpreting the results and asking ourselves if the way we've set up the action will actually get us to the results that we've modeled in the tool. And so, we've done the best that we can to represent these in the consequence analysis, but there's some interpretation that results and there's some uncertainties. And that's just because real life has uncertainties, right? In developing this plan, we have to think about how policies get enacted, funded, measured, monitored, maintained, enforced, all of that. Like that's part of policy design. And the EPS tool is great because it helps us understand the relationships between different kinds of policies for achieving climate action, and also offers the opportunity to test different scenarios, like different schedules, or implementing something sooner, have it enacted sooner. We can learn a lot from that. So if you're curious, if you're new to the Louisiana climate planning process, you can learn more from the Governor's Office website, and you can also check out all of the videos of the past meetings if that's something you're interested on the Governor's Climate Initiatives Task Force YouTube page. So with that, thank you again. Thank you to Olivia, Energy Innovation, and looking forward to using the tool with all of you. Thanks.
Thanks, Allison.
All right, can you all see my screen? Great. Okay, thanks for joining us. I'm Olivia Ashmore. I'm a policy analyst at EI. And as mentioned before, I'm joined today by Kyle Clark-Sutton, who's a program manager at RMI, whose team has been providing us the data we're using in the Louisiana model. Our model has been used and developed for many regions across the world. In total, we cover about 56% of global emissions with EPS models. This includes several state models in the US as well. The EPS is designed to help policymakers understand the impacts of energy and environmental policies, find the best way to meet their climate, financial, and other goals, and make policy decisions that are unbiased and data supported. To do this, we first create a business as usual scenario, which you can see is this black line at the top of this graph. That is developed using a variety of national data sources. For the Louisiana tool, we primarily use the NREL Electrification Futures Study, the EIA State Energy Data System, and sources from EPA to forecast emissions through 2050. The model uses an annual time step and includes the COVID recession, which is this dip you can see in the start year 2020 and 2021 emissions. And then we forecast growth through 2050. So the whole model runs 2020 through 2050. Once we have this BAU scenario, we can start to layer on policies, and these multicolored wedges down here represent the emissions impact of different policies in our NDC scenario. This green line at the bottom is the total emissions reductions achieved. There's many different policies that can affect energy use and emissions. The Energy Policy Simulator is valuable because it helps cut through the noise and identify which policies are most impactful and cost effective. So our goal is to help policymakers identify which policies will best meet their goals. And to do this, we offer a unique way of addressing the interacting impacts of emissions, so we can account for the interacting effects of different policies. So first, for example, I'll walk through one scenario where you're both conducting energy electrification or energy efficiency and cleaning the electricity grid. In that scenario, either one of those policies would have achieved 1 metric ton reduction on their own, but when you combine them together, you actually achieve a little bit less emissions reductions than if you'd only done one, because now that you've reduced electricity demand, the grid is cleaner, so there's fewer emissions reduced. But the opposite is also true. So for example, if you electrify vehicles at the same time that you make the electricity grid cleaner, you will achieve greater than emissions reductions than either of those policies would on their own. So we track these interacting emissions effects through a systems dynamics model. This allows us to predict the combined effects of policy packages, so we can look at how different policies impact each other, as well as total downstream emissions. We track this through stocks and flows. So for example, I'll walk through the transportation sector, where we track vehicle stock to determine emissions. I'll emphasize this is a simplified version of what the model does, but is a good example to understand how we calculate emissions and how different policies can impact those. So we start in transportation with annual travel demand. We take into account annual vehicle distance traveled and the number of retiring vehicles to forecast the number of new vehicles needed each year. We then can consider vehicle prices and operating costs to figure out which new vehicles are purchased that year. And this can be optimized to include endogenous learning. So for example, as more EVs are adopted, the price will come down and more EVs will be purchased. Once we know which vehicles are being purchased, we can use the fuel efficiency of the entire vehicle stock to determine total fuel efficiency. And we can then calculate vehicle emissions using emissions factors per vehicle. When we start to layer on policies, this will impact everything downstream. So for example, an EV sales standard will impact which vehicles are purchased, which then in turn can induce more demand for electric vehicles. A different policy is a fuel economy standard that would impact both operating costs and fuel efficiency, and may even lead to a rebound effect that increases the annual vehicle distance traveled. So we can account for all these impacts in our model. Another policy we include is a transportation demand management policy that reduces total annual travel demand in vehicles by shifting vehicle travel to things like biking and walking and public transit. This ultimately will reduce the number of vehicles purchased, the number of miles driven, and total downstream vehicle emissions. So the transportation sector is just one of the modules we include. We also include the buildings, industry, and ag models, and all of those feed into the electricity sector and the district heat and hydrogen sector. We include a CCS module that applies to industry and electricity. And then on top of all those, we have a fuels module that tracks fuel prices, and a research and development module that tracks how technology advancements would impact emissions downstream. We also have a land use module. All of these come together to provide a few key outputs. Those include pollutants, both in terms of GHGs and criteria air pollutants. And so from that, we can estimate health outcomes. And we also track cash flows in the model. And from the cash flow analysis, we can feed it into an input-output model that's embedded in the tool to calculate changes in jobs and GDP. Further breakdown of some of those subsectors within each module. Buildings include several different heating end uses and several different unit types. Industry includes over 20 different industry sectors. And so we track energy and emissions in each of these sectors. Transportation, we track several different vehicle technologies, as well as 2 different passenger modes and freight modes. We track renewable and non-renewable electricity capacity. And I'll just pause briefly to explain a little bit about how our electricity sector works in the model. We are using an electricity demand module that tracks electricity demand from the buildings and industry sectors, and then it forecasts what additional new capacity will need to be built to meet that electricity demand. So the model takes into account new capacity costs, operating costs, and peak electricity demand to determine which types of electricity capacity to build. To briefly talk about our calibration process, calibration is figuring out how well our inventory and emissions align to other sources. So we used very similar sources to what Allison mentioned. We looked really carefully at emissions results from the EIA, the Energy Information Association. We looked at NREL, Rhodium, and EPA's SIT tool. We also compared to Louisiana's state-specific inventory from 2018, and we crosswalked our emissions by sector to theirs and found we aligned really well. Our model has been peer-reviewed by several national labs, universities, and global partners. And whenever we work with a new group, we solicit review. So we've been working with folks in Louisiana for over 5 or 6 months at this point and had the opportunity to walk them through the model and solicit their feedback on our results. Thank you, and this is my email address. I'm now gonna pivot to showing you the online web version of the tool, which is now live for Louisiana. I just wanted to leave my email address up there and say that you are all welcome to email me with questions about the tool.
Thank you so much, Olivia, and thank you, Lindsay. Thank you, Allison. We do have one question. This question, and please don't hesitate to pop questions into the Q&A box. It's down at the bottom bar of the Zoom window. So this question is from Eric asking, how has the EPS changed Louisiana's planning processes? What would the process use for forecasting impacts without the EPS? And what are the main insights the EPS has provided so far? Which policies have been difficult to model or approximate? So a few different questions in there. So maybe Lindsay or Allison would want to take the first few ones, and then Olivia, you could take the last one about policies that may have been difficult to model.
Sure, I can kick us off and then I'll pass it to Allison since she's been very intimately involved in connecting our draft portfolio with the tool. The EPS has really revolutionized our planning process. We didn't have any way to track the emission reduction potential of our actions without this EPS tool. And though it's not a one-for-one connection of an EPS policy with a climate task force action, Allison has worked tirelessly on trying to align them as best we can. So this does give us a really good insight into what those potential impacts are at a Louisiana scale, because most of the data we have, and our team has done countless research on this, and we have wonderful experts involved in this process. But this is giving us that Louisiana specific data, not just for emission reduction, but as Olivia mentioned, also on potential public health benefits and impacts of policies, as well as on economic input and output with jobs. And Allison, I'll let you take over with that question on insights and policies difficult to model. We have had quite a few of them.
Yeah, I think some of in the first round of consequence analysis that we did in June, it was tough to model because our hypothetical portfolios were so high level. And so it was tough to translate that into the EPS policies, which are, force you to make some user generated decisions on inputs like schedule and about turning various policies on and seeing what happens. And, when we were trying to test different approaches in constructing those, we had to work through, what would be a reasonable approach to doing that. And that's why we had to supplement it with some desktop research. But I think in the absence of the Louisiana EPS, we would have had to use national data. We probably would have used the US version of the EPS, and I'm not sure how that, I don't think it would have led us in the same direction and gotten us the same kind of detail that we need for some of the, especially on the industry side, some of the policies that we're looking at. And I would say that the things that are hardest to model are some of our policies are more, or some of our actions are more related to implementation, in terms of how we do things. And they're not necessarily quantitative in the way that you can use in a numerical model like this. I would say another challenge is land use impacts, because this is an energy demand model, an electricity demand model. It's difficult to model some of the land use impacts, which is why we're supplementing the tool with additional research being done on carbon sequestration and land carbon sequestration being done by the Institute and CPRA and some of our partners at USGS. So that's one of the challenges I think that we're trying to address. And not everything can be done with the tool, but the tool helps us see some of those relationships between policies. And it's also helped us get a sense of what's most likely to be most intense, give us the biggest bang for our buck in terms of reductions by 2050. That's been super helpful.
Olivia, I'm going to pass the next question to you, and also feel free if you wanted to add anything about modeling challenges. But one of the next questions is, let's see, do you, I think you answered it online, Olivia, but I think for the benefit of the group, if you want to just explain a little bit about how you split industry and agriculture.
Yeah, we do split industry and agriculture. We track, I think I mentioned, over 20 industries separately. So that includes agriculture. And we also track the land use emissions associated with agricultural practices. And I can show you how to do that in the tool.
And let's see, what other questions do we have here? This one, super interesting question from Alexander. Can you please expand on the specific policies that would contribute the most to reductions in industrial emissions? Here in Louisiana, most of our emissions come from the industrial sector, and many of these facilities have unique plant-specific designs and profiles of energy usage and emissions. So can you expand on which policies lead most to those reductions and on any uncertainties you have in this analysis?
So Olivia, would you like to start on that one?
Well, I'll just briefly say that there's a lot of policies in the Energy Policy Simulator that can impact industrial emissions, and we can show you some examples of what are the most impactful ones. I think in Louisiana specifically, Allison and Lindsay have the background on which policies they're considering.
Yeah, we're going to get into this somewhat next Tuesday at the task force meeting. But yeah, there are multiple policies available. I'd say the biggest one that we're looking at is electrification and fuel switching. So trying to move thermal emissions in industry to electricity and to hydrogen to substitute for high temperature fuels. So those are some of the most impactful ways in the model that we've seen to reduce industrial emissions, but more to come on that next week.
And there are also, alongside of that, a lot of enabling actions that we've tried really hard to use the tool in modeling, but no, it needs to be complemented with our Louisiana specific lens. So we need to expand transmission infrastructure, green jobs, and the green job pipeline. So there are other actions that go alongside of that, but Allison's exactly right that electrification, green hydrogen, industry efficiency standards are really big components.
And this is probably a question I'm thinking for Lindsay. I see equity is one of your objectives. Can you talk about how you select the task force and subcommittee members? And do you feel that they're representative of all Louisianans?
Sure, absolutely, Laurel. We selected, so the governor selected our climate task force members, and our task force members are, certain members are chairs of our advisory groups or committees. So I worked alongside our chair of the equity advisory group, who was appointed to that position on the task force by the governor. And we worked on developing a robust lay of stakeholders that could be engaged in the equity advisory group. So we do have those that are representing Indigenous people and different tribal communities in Louisiana, as well as researchers on the more qualitative and quantitative sides of equity, alongside those from the labor unions and that are more on the ground with communities as well. And those also that are activists and advocates for environmental justice and for equity in communities. So tried to bring in people not just from the high level policy world, but also who are on the ground. So we do have 140 people engaged in this effort. I do say all the time that that doesn't excuse us from engaging the public in this work, because that is a lot of people, but it is not entirely representative of Louisiana. So we tried to supplement, though it is a robust stakeholder group, we also need to be engaging communities directly.
Thanks, Lindsay. And a next question comes from Scott. Since the majority of carbon capture will involve gas pipelines, each of which impacts an average of 500 acres of coastal wetlands, is there any flow or linkage between carbon capture and the implied wetlands impact, or any analysis of enacting a policy like banning carbon capture from the coastal zone, thus delinking the wetlands impact from carbon capture? Allison, is that one you want to try to take, being from the Water Institute, or Olivia, you want to tackle that one?
Well, I'll just briefly say that our model is technology neutral, and so we want everyone to be able to model whatever policy scenario they want in the tool. So you can absolutely model CCS in a policy package you put together, or you could leave it out. It's entirely up to you. We just want to enable decision making around that. I think I'll say that in terms of the wetland impact, that's outside the scope of our modeling, but I know Allison has worked a lot with folks to study the impact of wetlands and climate, so maybe she has some insight there.
Yeah, I don't know that we're necessarily looking at the ways in which wetlands and CCS would connect, like the impacts of those together. That's, like Olivia said, that's a little bit outside the scope of what the model can do. But I think part of the advantage of this planning process and the way we've structured it is that the model is not the only answer. It helps us design policies better by giving us outputs that we can interpret in based on what we know about what went into it. So I think that's just one of those things that is going to require really careful policy design.
Thank you. Thanks so much. So I think we're going to hold on the rest of the questions for now so that we have time for Olivia to actually do a short demo of the tool and show you a bit about what it can do, its capabilities.
Can you all see my screen again? Great. Okay, so this is the landing page of the Louisiana tool. I'll just point out a couple buttons. Up here is the Learn More button, and this will take you to the documentation for the tool, which is available here, and then the documentation for the model, which is available here. And I'll just give you a little preview. It looks like this, and then there's really specific breakdowns of how each sector is calculated. And it's all open source and documented. So you can download the entire tool right here, which includes all of the data files used in the model as well. When you're back on this landing page, you can click this Enter Simulator button to bring you to the home page of the tool. This original line here is the business as usual projection that I talked about. And then the graphs will all have a label for the axis to tell you the units. We also included a couple targets here to show the Louisiana governor's targets. Up here, I'll draw your attention to the output graph selector. And this is a drop down of all of the different topics we have for different graphs available in the tool. Some of my favorite ones are some of the electricity sector ones because they're colorful and you can look at the forecasted electricity generation through 2050. I also want to point out that here there's a further breakdown within each output graph topic. There's additional graphs you can look at. So for example, this is capacity instead of generation. But this is how the kind of graph selector is laid out. Up here, I would encourage you to make an account. That way you can save and name your scenarios and share them with other people. You can also download your scenario results in table form and make your own graphs from them. And then when you want to start putting together your own scenario, you're going to come to this left-hand side where it says Policy Scenario Selector. Here we have, as I mentioned, the one pre-built scenario, which is just an example scenario that was developed for the US as a whole. So it's not Louisiana specific, but it can help demonstrate some of the functions of the tool. So that'll look like this. And you'll see this green line shows the emissions reductions in that scenario. Some of the helpful graphs here are the wedge diagram, which I included in the PowerPoint, which shows the contribution of each of these policies to total emissions reductions. I'll also just quickly show you the CO2 abatement cost curve, which if you're familiar with the McKinsey cost curves, shows the relative impact and cost of all the different policies included in our scenario. I also really like this jobs, GDP, and cash flow graph. That can show you the estimated change in jobs in your scenario, as well as the change in GDP, percent change in GDP, and then some further breakdowns of job changes by direct induced or union or non-union jobs. Another really useful graph, I think someone mentioned equity. We do track some human health and social benefits in the tool. So here you can see avoided mortality in the NDC scenario and the contribution to each policy to avoided mortality. So here, the biggest one is reducing fossil fuel consumption in industry, and that accounts for the majority of avoided mortality here. We also track a few other outputs, including asthma attacks, hospital admissions, et cetera. And those breakdowns are here. I'm gonna do a quick demo of how you can make your own scenario. So I'm just gonna pivot to this new scenario, which will give us a clean slate here. Just for an example, I'm going to go industry. And when you click this drop down, a bunch of different policies will pop up. So for carbon capture and sequestration, this is a little overwhelming, but we list all of the industrial sectors here. As you can see, they're all set to 0 by default, and they're all checked. So you can use this check mark here to either select or unselect all, and then you can use the slider up here to set the policy. So for example, if you only wanted to set the policy for the chemical sector and the refined petroleum sector, you could just check those two and drag the slider. This will automatically show you the emissions reductions in real time. So the model's calculating everything live. And then you can also look at your wedge diagram to see, we only have one policy here, but you can see the contribution of your policy to the scenario. By default, everything will phase in linearly from 2020 to 2050. So if you would like to change that, you can customize the implementation schedule by adding the year you want it to be fully implemented. For example, if we wanted everything implemented by 2030, we could add that here. Just click this plus button and this will automatically update. When you press OK, the graph will update as well, and you can see you achieve the emissions reductions by 2030 instead of 2050. I think it's probably best to turn it over to questions. I'm happy to show you other features of the tool. I think someone asked about the agriculture sector. We track that here, so you can see their agriculture emissions specifically. You can also see additional industry breakdowns here, industry fuel use, and we track all the different sectors here. All right, I will stop sharing so we can do more Q&A. If people have any questions about the tool, I can put it back up on the screen.
Thanks so much, Olivia. Does anyone have any further specific questions about the tool itself? Okay, well, I think then it's okay to wrap up unless anybody, Lindsay or Allison, did you want to offer any final remarks? Oh, you know what? We did have a question. Thanks, Scott. Okay, we'll get to this one question and then we'll wrap up, unless there's other questions. Scott is asking, would you mind walking through the definition of methane capture in the tool? Good question.
Absolutely. I will actually use this as an opportunity to show you our guidance in the tool that we have built in. So can you all see my screen again? Great. Okay. So within the industrial sector, we have a couple policies. We have both methane capture and methane destruction. Methane capture would reduce leakage in the natural gas system, and methane destruction would combust it instead of leaking it into the atmosphere. In this methane capture breakdown policy, we can see we have a few different sources of methane. And if you want to learn more about this policy, we have the description here. We also can explain how the model handles this policy and how to design this policy well. And that guidance is built into the tool. It's not specific for Louisiana, it's standard for the US model as well, but you can click on these links and it'll explain to you how the tool is tackling methane capture and what's a reasonable policy setting. Hopefully that answered your question.
And then one other question, I think it says, I wonder if you could expand on the physical likeliness for the CCUS scenario. Alexander, correct me if I'm interpreting that wrong.
Again, I can say we have some guidance in the tool, but it's not Louisiana specific. So I think for technical guidance in Louisiana, we would look to your in-state experts to determine that. In the tool, we have a little bit of guidance for CCS. You can see here, when you click on this, learn about this policy, that we recommend setting the policy to no more than 20% of total emissions due to the technology still developing. However, if you reduce the majority of industrial emissions through electrification and hydrogen, you can set the remaining CCS policy to up to 100% to determine and capture like which residual CO2 emissions are available. So I would say it's variable, and I would consult in-state experts on what is appropriate for Louisiana.
Lindsay or Allison, anything to add to that one? No. Yeah. Okay.
I'll just point out that we have several draft actions around CCS in the draft portfolio, and one is about understanding the physical like impacts of CCS. And so that's already, you know, we understand that there's more work to be done to understand the impacts there, and we've already included it in an enabling action in the portfolio to that end. So just wanted to bring that up as well. And on usability of the tool, I just wanted to offer a couple of tips that I've learned in using it. I definitely echo Olivia, make an account so you can save your scenarios. But when you're using the slider in, especially on policies where you have to click, select more than one thing, you don't have to select them all. You can use the top button to deselect, and then choose which ones you want and set the slider there, and then unselect those and then move on to the next one. So you still have that variability for things like on CCS, for example, you can select only the process emissions, or you can select thermal emissions for a specific industry or something like that. And that's also how you vary the schedules as well. So just a little, I also think it's fun to work from an established one, whether it's the business as usual and starting from there to add things, or starting off from the US NDC scenario and saving it as a new one and varying it up from there. So good luck. It's fun.
Just to add to Allison and Olivia's comments, Alex, your question about CCUS practicality gets to a bigger question and applicability with the tool. As Olivia was showing with many of those tools, just because we can set it to 100% implementation by 2025 or 2030 or 2050, doesn't necessarily mean that that's applicable in Louisiana. So that's the necessity and the role and niche of our task force, is helping us figure out when can all of this be implemented and what are the policies, what are the enabling policies that will make this happen. So just thinking about those as being paired together, it's not that we're following the tool exclusively, but having that guide us in developing those actions.
And a question from Francesca: are municipal and industrial waste management policies included in the tool? For example, reuse or recycling?
Yes, we include an industrial material efficiency policy that addresses the efficiency of inputs into the industrial sector. And there's also some policies that address kind of like embodied carbon emissions in the cement industry. So you can reduce the emissions associated with producing cement in the tool.
Okay, I think we have answered our questions. And Lindsay, maybe you want to just close us out. As you do, I'm just going to pop in two websites. One is our newsletter sign up. So if you want to know about any updates to the Louisiana EPS, you can sign up there and you'll learn about our any new versions that we release. And then also the Louisiana Climate Initiatives Task Force website, so you can stay up to date on what's happening there.
Thanks so much for sharing that, Sarah. So as Allison mentioned, we have a task force meeting next week of our 23-member climate task force, where we'll be looking at how our draft portfolio, so kind of our draft climate action plan, gets us towards our emission reduction targets through using the EPS tool. So that's a scenario that we've been developing and working on a lot. And so we will be going through that with our task force next week. But this tool is live. I'll be sharing the links with all of those of you who are on our climate listserv later on today, but please do feel free to sign up for our listserv through that link that Sarah shared if you're interested to keep updated with the work of our climate task force. I just want to thank the Water Institute of the Gulf and Energy Innovation again this work would not be possible without you all. And we're really excited to see how this can apply and further all of our work through the Climate Task Force.
Thank you so much. And thank you to everyone for attending. Bye-bye.
Thanks, everyone.
Thank you. Have a good afternoon.